My name is Ram Vijay Krishnan. I'm a postdoctoral researcher here at the University of Liverpool, and my research mostly focuses on chemistry automation and to see how robots work inside chemistry labs. So my research mostly focuses on chemistry automation. It works to see how we can use robots inside chemistry labs and how they can perform experiments similar to how human researchers would. Traditionally, how researchers would work inside a normal lab, we would use multiple pieces of analytical equipment. For example, we would use a mass spectrometer to see how heavy a molecule is, but we might use NMR to see how the atoms inside the molecule are connected together. And so typically in traditional automation, you'd only use one piece of equipment, but here the fact that we've used NMR in combination with MS provides a very data-rich representation of how experiments are done inside an automated setup. So for us, it was really to see how we could not only speed up the pace of research, but also to expand upon the types of problems that we could do. So to think of more experiments that simply would not have been possible without the help of automation. So inside our experiments, we use, for example, AI, and they work on high dimensional data. And this is very difficult for humans to work around themselves. And so the automation really helps feed the AI model so that we can think of more expansive experiments. So my research mostly focuses on closed loop organic synthesis. So it's to try and emulate how human researchers would go about making a product, characterizing the product, and then moving on to further purification and assay purification. So my research mostly focuses on how we can use robotics to try and automate all steps inside this process, including the decision-making process. So for us, it's been really critical because it's also limited the amount of time that we have to spend inside the lab, and it allows us to think of more expansive problems and to spend more time actually designing the experiments, which is the real difficult bit inside chemistry. And it provides us with the volume of data that we need for our research. So the ChemSpeed platform allows us primarily to not have to do the experiments ourselves, so it works much faster than we can, and it also limits our exposure to dangerous chemicals. So inside our laboratory, our mobile robot transports the samples to our Fourier 80 system, and then the Fourier 80 automatically acquires the data, and then we use algorithms to process that data automatically, and then decide what the next step in the experiment is done automatically. So both these analytical techniques, traditionally automation has been done using only one characteristic method, and that's not a very complete description of how reactions happen in reality and how researchers work. So traditionally researchers would combine multiple pieces of equipment, and this hasn't really been done before. So for us, like when we use our mobile robots to combine these two pieces of equipment, we get a much more data-rich representation of what we do inside a reaction and bring our decision-making much closer to how a human researcher would operate. So our next goal is to try and integrate more advanced artificial intelligence inside our robots so that they can do much more complex decision-making tasks than what we've demonstrated previously. We're also interested in trying to include technologies such as large language models inside our robots so that they can do much more expansive data searching and then data analysis.